Hello everyone, this is Professor Chan for Math 1245 online class. Today we're going to be going over section 2.2, which is symmetry and even and odd. So we're going to do majority of 2.2. I do want to make a quick correction based off of our last video. If you were not watching the prior video, I said that 2.1 contains symmetry, and that is not true. Symmetry falls under 2.2. So I do apologize for that, but let's start. Okay. So when we talk about symmetry, we are talking about whether something reflects over a specific situation. So we have a bunch of different ones. We have symmetry with x-axis and y-axis and by origin. So I'm going to do the first two together, and I'm going to talk about x-axis and y-axis. So symmetry with x-axis means reflects over the x-axis. For every point that you start off, which is x comma y, you're going to replace it with x comma negative y. So every y gets replaced with negative y. For every point, so that's going to be your issue for x-axis. So symmetry with y-axis is just going to be the opposite. You're going to reflect across the y-axis. So when you replace every x comma y, this is going to be negative x comma y, and every x will be replaced with negative x. Now, this may be a little confusing to some of you, and it's easy to get your x and y's mixed up. Okay? Now, just remember that all you need to do is just kind of visualize. Okay, it's pretty easy, especially if you are dyslexic or you have a problem with order. The better way to do this is to kind of look over the visualization of what's happening. Okay, so let's take a look and let's just do a quick recap, right? So I have a graph here, and this is my x-axis, and this is my y-axis. Okay. So let's give an example for both of these, okay? So I'm going to scroll down right here. And I'm going to use 1 comma negative 4. So 1 comma negative 4 is going to be my starting point. So they're always going to give you a starting point, which is 1 comma negative 4. If I am doing symmetric over the x-axis, so if I'm doing symmetry in regards with the x-axis, right, that means it's going to flip over the x-axis here. Whoops, sorry. So since my original point is here, which is 1 negative 4, it's going to flip all the way across. And these 2 points, let's talk about these. These 2 points will have equal distance away from my x-axis. So my original point, which is 1 negative 4, it's going to flip up and it's going to be 1 4. So my y-coordinate changes coordinates or changes signs. Okay? So this will be my, sorry about that. This would be my answer for my symmetry in terms of the x-axis. So it'll be 1 comma 4. And as you can see, if you guys scroll back up, right, if I am reflecting over the x-axis, my y changes signs, okay? I do want to clarify this. It does not mean your y turns negative. It just means it's going to be the opposite sign of what you had originally. Okay? So let me show you what happens when I am reflecting across the y-axis. So the y-axis is going to look like the following right here. So remember, you're always using your original point for reference. You're not using this one. You're using the one that we have originally. So 1 negative 4 flips over, and this is going to be negative 1 negative 4. Okay? So this is my point right here, right? It's flipped across a y-axis. They're both equal distance from the y-axis, so my answer is going to be -1, -4, okay? So for the following, let me just kind of talk about this, right? So the way to kind of help you understand the difference is just simply knowing where your x and y axis comes from and then reflecting visually from there, right? And some of you guys, if you guys kind of struggle with this, you should just kind of do with what I'm just doing right now, which is just making a graph, right? And then seeing where it reflects in respect to your x and y axis. Okay, and that will kind of help solve sometimes the weird disorientation of like x and y. Just think visually what's happening as you're doing it. Okay, so the last type of symmetry is symmetric by origin. So what does symmetry by origin mean? Symmetry by origin means the following here. It means that you are doing this, that you are rotating 180 degrees, okay? And for every x comma y, you're going to change signs for both. So x becomes -x, -y becomes -y, okay? And so idea whatever it was originally, it's going to change signs for both. So origin's essentially just a combination of the first two above. So let's talk about this one right here. So if I'm starting off with 1, -4, what would happen if I rotate around the origin? This is what's going to happen. So 1, -4, both x and y values will change signs, and it'll actually land up here, which is -1, 4, right? My original x was 1, changes to -1. My original y is -4, changes to 4. And let's remember, what's your origin? Your origin's at 0, 0, okay, for the following. So if I'm rotating 180 degrees, right, 180 degrees, if you guys are not familiar, means it's half a revolution, right? So idea is this point here is going to rotate 180 degrees, and that actually gets to the point that I'm at. If I rotate another 180 degrees, right, I'm actually making a full revolution, and I'm actually back to where I start. Okay, so this is what actually happens right here, okay, for the following. Okay, so my final answer for this one is going to be the following. It's going to be -1, 4. Okay. So I think this should be pretty straightforward when you're doing symmetry in terms of points for the most part. Now, if you have questions, feel free to send me an email, but for the most part, it should be pretty easy to kind of distinguish, okay? And once again, if you're not sure, use your visuals to kind of help you. So let's move on to the next type of symmetry. So the easier one is one we just did before with symmetry in terms of coordinates. Now we're going to do symmetry in terms of graphing functions. So we want to determine the symmetry for y equals x squared minus 4. Okay, so let's look at this example right here. So actually, before we do that, let's just do a quick recap, right? So idea is if I want to do symmetry with x-axis, y gets replaced with -y, x gets replaced with -x, and then origin, it's both, right? So idea is we're just changing signs for the respective letters. So if I want to figure out whether it's symmetric by the particular graphs, this is what we're going to do. We're just going to test all three. Okay, so let's take a look at this one right here. So if I want to do symmetry in terms of my x-axis, this is what I'm going to do, right? This is saying I replace y with -y. So if I look at this right here, I'm like, okay, so everything's going to stay the same except I'm going to replace y with -y. And I simplify it and it looks like this. I can clearly see that this one right here is not the same as my original. Okay, so how do I know something is symmetric? If I do this, whatever substitution that I do, if it remains the same, it's symmetric. If there is a change, and when I say change, it includes sign change, it will not be symmetric. So if you notice, my final answer for replacing y with negative y is not the same that I have original. So we can clearly see, right, that this is not going to be symmetric here, right? So this one will not work, okay? So let's look at symmetry for y-axis. So y-axis, I'm going to do the opposite. I'm going to replace x with negative x. I look at my original, and I have y is equal to x squared. I replace x with negative x. Make sure you put that in parentheses. Okay, and I have y is equal to x squared minus 4. This one actually does work. So it's symmetric by y-axis. And then I'll do by origin. And I'll replace them both. Let's look at what happens. So I'm going to do parentheses negative y. Sorry, my left parentheses disappeared. But I have negative y equals x squared minus 4. That clearly doesn't work. Okay, and then you want to state that it is symmetric towards y-axis. Okay, that is your final answer. Okay, so when you're doing this on your test, you must show your work, and then you must state what kind of happens at the end. Okay, for the following. Now, if you're not sure, all you have to do is graph. Now, word of caution, you cannot state that you know which it is symmetric by solely based off of your graph. You must show mathematical work, which is what we just did here. But if you're not sure if you did it correctly, you can check through your graphing. Okay, so I'm going to turn on my graph. Let's clear things out. Remember, you hit the y equals button. I'm going to type in x squared minus 4, and I'm going to hit graph. Now, if you don't see the screen, remember, go to zoom and go to 6. So I can clearly see that this is symmetric towards a y-axis. How do I know? Because if I look at my cursor, right, this y-axis cuts my graph into 2 equal halves. So this is symmetric. It's not symmetric by the x-axis because notice if I'm going horizontally, right, this portion here is not the same as this portion up here. Now the last one, origin, a way to help you determine is if you flip your calculator upside down, okay? Now obviously I can't do this because I'm using my laptop, but if I flip my calculator upside down, my graph should look like the same, okay? And it's definitely not, because if I flip my calculator upside down, my parabola is actually going to go down, right? I kind of have this U shape, right, originally, but if I flip it upside down, it's going to be an upside down U. So obviously it's not going to be symmetric. So okay, let's do one more example here. I'm going to do number 3. So let's take a look at this right here. I'm going to do symmetry in terms of the x-axis. So that means y becomes negative y, and negative y is equal to x cubed plus 3x squared minus 4x. That does not work, as you can see. These two are not the same. So no dice. Let's do symmetry by y-axis. And I'm going to replace x with negative x. So what I'm going to do, is replace x with negative x. Again, put this in parentheses here. Sorry about that. And I get the following. And this is not the same either, so this one doesn't work. Let's try to do our last one, which is symmetry by origin, which is x by negative x, y by negative y. So I have the following here. Nice thing about problems like this is, if you notice, I don't really have to kind of work this out again. If you notice, this is very similar to ones that we just did, right? So if I look at this here, this is going to come out exactly the same, right? The right-hand side will be negative x cubed plus 3x squared plus 4x, because we just did that. And then my left-hand side will be negative y. This will also not work, so let's say not symmetric. Okay. I purposely wanted to do this problem with you because you will have situations where it's not symmetric at all, and that is very possible. So you could have it where it's not symmetric at all, and you may actually have a situation where it might be symmetric into maybe 2 ways, or maybe even symmetric all 3 ways. So just make sure you check all 3. Okay, it may not necessarily be one of the 3, although that is very common, but there are possibilities where it could be nothing, or you could have more than one way, or more than one aspect of symmetry. So just remember that you'll have symmetry based off of points, and then you'll also be asked to do symmetry in terms off of graphs. Okay, make sure you know how to do math for those, both of those, and then also make sure you know how to do the visualization, and that's going to help you a lot for the following. So let's move on. So I'm going to do another portion of 2.2. This is very similar to what we just did. Okay, it's called even and odd functions, and it actually lends itself very closely to what we did with symmetry. So let's talk about what is even and what is odd. Okay, so even, what does even mean? Even means the following. It means that it is symmetric towards the y-axis, which is what we just did, and then we did odd is symmetric by origin. So let's remember symmetric by y-axis. Sorry, origin. So let's talk about symmetric by. If we look up, right, symmetric by y-axis means replace x with negative x. Now we do have to be a little bit cautious because we're talking about functions. So we want to say f of x is being replaced with f of negative x. So let me just do an example. So how do we know something is even, right? All we will do is we'll do f of x, and we'll figure out what f of negative x is. If they both end up being the same, then it is going to be even. So f of negative x, according to this problem here, I'm going to replace x with negative x like this. So this is going to be 2x to the 4th, and this is going to be minus x squared, okay, because this negative cancels. This negative cancels because you're squaring it, but then this minus stays down. They're both the same, so this is going to be even, right? F of negative x, this is f of x, this is f of negative x. They're both the same, so it's even. So the rule for odd is this. F of negative x has to equal to f of negative x. Sorry, negative f of x. Okay? So I want to show this to you right here. And our example is 3x cubed. So what I'm going to do is I'm going to list each one out separately. So I'm like, what is f of negative x? I'll replace x with negative x. This is what I get. And then I'll do negative f of x separately. Now what does that mean? That means I take my negative and I put it in front of the entire function. So since my original function is 3x cubed, I'll put negative in front of 3x cubed. And then I'll simplify it. Notice they're both the same, so hence this is odd. So let's do some more specific examples. I'm going to scroll down here. And let's look at this one right here. So, number 5, I'm going to do the following. So I'm going to the strategy is I'm going to do this, where I'm going to look at f of negative x and negative f of x separately. Okay, so f of negative x, let's look at this one. So this is doing the following. This is going to be negative x cubed plus 4 negative x squared. And this is negative x cubed plus 4x squared. So I figured out f of negative x. So I want to see, so if I notice, let's look at f of x and let's look at f of negative x. And I notice they're definitely not the same, right? So because of that, it is not even. I'm going to now try to do negative f of x. Okay. Now I know for it to be odd, right? The rule is negative f of x has to equal to f of negative x. Okay. Now the nice thing is we already know f of negative x, so all I need to do is do negative f of x. Now we need to be a little bit careful about this here. This negative applies to all. So it's going to distribute to all my terms and it's going to look like this. Okay, if you do it like this right here, this is incorrect. Does everyone see that? Because you're only applying it to the first term. You need to apply it to all of your terms right here. So this do not do, right? This one is wrong. So I'll distribute this. This is negative x cubed minus 4x squared. I look at this one here. And I look at this one here. They do not have the same signs because the 4x squared, one's positive, the other one's negative. So this one doesn't work. It's not odd. And we have a special case where it is neither. Okay, and that is possible. You can have something that is not symmetric you can have something where it's not even and it's also not odd as well. And that is very likely. Okay, so now majority of the time it's generally going to be even, odd, or neither. It's very rare that it'll be both, but do check it out just to make sure that that doesn't happen. Okay, fine. Let's look at one more example for the following. I'm going to look at number 4. I'm just giving myself some space because this one's a little bit longer. So same thing. I'm going to do the following. I'm going to figure out my f of negative x. That one's pretty straightforward. So I'm going to replace my x with negative x here. And this is negative x over x squared minus 1. Okay. As you can see, f of x does not equal to negative f of x. So that one clearly doesn't work. for the following right here. Now, when I do negative f of x, I do have to be a little bit careful here, right? So a lot of people, when we do this part, people are like, well, why can't we do negative on top and bottom like this? Okay. The problem is if I do that, right, they both actually end up positive. So this one is actually not helpful, okay? So I actually do not put a negative for both the top number and the bottom number. Sorry, top and bottom. So I only just pick one of them, okay? So let me kind of reiterate. If I put a negative both on the top of the fraction and the bottom of the fraction, they will actually just cancel each other out. So we actually do not want to do that. So what I'm going to do is I can either choose one of them. So if I choose a top, right, it actually ends up being the same, which works, okay? Now, let's say you decide to put the negative on the bottom, and it looks like this. Now, initially it doesn't look the same, obviously, right? So you're like, negative f of x doesn't equal f of negative x. You do have to be very careful because there are problems that can be a little bit tricky. Make sure you simplify your signs as much as possible so you can see if they align or not. So if I notice here, they may look different, but I notice the signs are all opposite of each other. So one thing I could realize is what happens if I multiply top and bottom by negative 1? What will happen is this will become negative x, and then this one distributes. If I multiply negative 1 with 1, this becomes negative 1, and negative x squared times 1, which is positive x squared. So as you can see here, right, these two are definitely the same. And also this one as well, if you happen to do the top one instead, okay? But as you can see, f of negative x does equal to negative f of x, so this one is odd, okay? And just want to clarify once again, the negative f of x is the one that kind of messes up people the most because a lot of times they only apply it to one term when you should apply to all, and when it comes to a fraction, make sure you only apply to either the top of your fraction or the bottom part of your fraction, right? Remember, also called your numerator or your denominator. So you only want to apply the negative to either your numerator or your denominator, but not both, because otherwise it will cancel out. And then once again, one last thing, if you're not sure, you can graph it. But then just as a quick reminder, remember you cannot use your graph to show your work. This is just for you to double check. So I'm going to graph this. Now, if I want to graph this, I need to be a little bit careful. I'm going to do the following. I'm going to put my x in parentheses. Sorry, let's clear this out. I'm going to put my top number in parentheses, and then make sure I group the bottom part in parentheses. So this is what it looks like right here. And I'm going to graph this for the following. Okay. Now, once again, my calculator is fixed because I'm using a laptop, but if you're following along and you graph this, flip your calculator upside down. Your picture should look exactly like what mine is currently. So remember that. If it's odd, if you flip your calculator upside down, the picture should actually be exactly the same for the following. Okay. So that is pretty much it. Okay. So let's just do a quick recap of what we did. We did symmetry in terms of coordinates and then in terms of functions, and then we did even and odd, okay? Should not be very difficult, but you want to make sure you practice this. Again, you need to make sure you know how to do the mathematical way, and then you can use the visual aspect to kind of help you see if you got it correctly. Okay? If you have any questions, send me an email or post on your discussion forum. But other than that, that's pretty much it. Okay. Next video, we'll finish the rest of 2.2, and we'll end right here.